So this is going to be a scanning interface for typical CB radio. This one I'm designing pretty much based off the Cobra Uniden Galaxy design. So this interface will work on like radios similar to like your Cobra 148 or DX959, 949 Galaxy radios, the Uniden sideband radios and AM radios, as they all use the same PLL and very identical schematics. Actually, a lot of the same manufacturers produce the boards for these radios. The guinea pig is my old Texas Ranger TR396FC. It really didn't have any use for this radio. It was just sitting on a shelf, so I figured I'd rip her apart, guinea pig her, and get this scanning interface going. And then afterwards, it's going to be transplanted into the DX959 that's in my truck. So there's 3 parts, well actually really 4 parts that we really have to worry about for this mod. We need to interface the rotary encoder, which is basically just a switch that rotary encodes in binary. So it's actually pretty intricate inside here. It counts in binary every time you turn the switch. It increments 1, well, more or less. I'll get to that in a minute. And that goes to the inputs of the PLL to tell it what frequency to tune. So that's the first thing. We need to basically interface and get and intersect this so that we can isolate it and actually scan through the frequencies. The other thing we want to do is we want to interface the Squelch so that when the Squelch breaks, obviously you want the radio's audio to open up and stop on that frequency once you've scanned to a frequency that's got a signal on it. So that's something else that we're going to do. Now, let's say you hear a signal on there and you want to respond to it. The other thing we want to do is we want to also interface the push to talk on the microphone so that when you key up to respond to this signal, it'll give you a little bit of a longer delay before it resumes scanning, just in case it takes the original message sender to respond to your message. Aside from that, the other thing that we're going to want to do is naturally put a switch on the front somewhere that you can go between normal and scan. Now, the way that we're going to interface the switch on this radio is basically we're going to use a microcontroller, and we're going to take all these leads here. There's 8 wires. It's an 8-bit system, and we're going to interface it with the microcontroller. In the scanning off procedure, basically the microcontroller is going to look at whatever this dial is set to, and it's going to say, oh, you're set to channel 5. You're going to output channel 5 to the PLL. Now, if you flip the scan to on, it's going to ignore the settings on here, and it's just going to start counting and increment. Another thing we could do if we wanted to add more features, we could add speed control for the speed of the scan, but we'll worry about that at a later date if that's what we decide to do. But it'll start incrementing one by one, and it'll start at channel 1, and and if the Squelch is open, it'll stop there. If the Squelch is not open, it'll increment to channel 2. If the Squelch is open, it'll stop there until the Squelch closes, and then it'll go to channel 3. And of course, we'll have a delay after the Squelch. We'll have a little bit of a delay so that the thing with the scanning, so that it will sit on the channel for a couple seconds, maybe 3 seconds or something like that, after the Squelch closes, just in case, like for example, if you're listening to a conversation or something, you want to hear both sides of the conversation. You don't want the thing to immediately resume scanning and jump away 40 channels, and by the time it gets back to the channel you were listening to, you're in mid-speech listening to the person returning the other half of the conversation. So we're going to put a delay in there as well. Now, the interesting thing about the output of the encoder is it's not just a simple, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 40, representing the channels. That is because the PLL actually operates at a much wider range than the 40 channels allocated to CB. And this is why a lot of people will do the mods on their radios that will allow them to tune to frequencies above and below the CB band, which is illegal. But because the PLLs have the ability to tune to those frequencies, they'll do that, and they'll open up those options, wideband their radios, and then they've got a radio that they might be able to move into the 10-meter amateur band or something like that. Now, I wasn't able to find a truth table for the inputs to the PLL, so unfortunately what I had to do is I had to turn on the radio, and I had to go put my multimeter in every single one of these pins, measure each single output, and change the channel. Measure each single output and change the channel, and repeat myself. And I did that for all 40 channels, and I built myself the truth table. I've color-coded the truth table with the corresponding wire colors for the output of the rotary encoder. Channel number corresponding to what the binary sequence is, the binary string, and the decimal representation, and naturally the tuned frequency of the PLL. Now, if you look closely, you'll notice that it doesn't quite go in sequence. For example, we got 91, 92, 93, and it jumps right up to 95. Well, the reason for this is actually because the allocations for frequencies in the CB band actually, instead of jumping up the typical channel increment, this one actually jumps up twice the channel increment, double channel spacing. And the reason for this is there's actually another channel in between here that's not allocated to the CB band. There's actually 4 of these channels. They're right in between channel 3 and 4, channel 7 and 8, channel 15 and 16, channel 19 and 20. These are allocated to things like radio control cars and stuff like that. So we're going to want to emit these frequencies because you don't want the radio to accidentally, I mean, it's not an issue to listen to it, but you don't want to accidentally key up the radio and tune out of band. It's also going to throw off what the display is showing you for the represented channel that it's tuned to. So basically, we'll just have to add a little bit of code in there that tells the computer that once we're above channel 3, we have to add 1, and then once we get up past channel 7, we got to add another one, and just do an extra increment before we actually tune the PLL. Thought this mod was going to be a piece of cake. Figured I would intersect the output from the rotary encoder and in between it and the PLL, and just ignore the rotary encoder when scan's enabled, scan it, just like I mentioned earlier. Now, once I looked at the schematic, this is a schematic of the DX959, got the rotary encoder right here, and you notice the rotary encoder, you got your output lines, they go over to the PLL, PLL's got pull-down resistors on the main board. The interesting part about this is the rotary encoder also controls the output to the 7-segment display. So, in order to get the proper display, we can't use the rotary encoder outputs for the display, because it'll just show the number that whatever the encoder is tuned to, whatever binary sequence the encoder is tuned to. So we're going to have to basically cut all of these traces and isolate them, and then run the display output through 7-segment drivers. So, got a schematic here. It's kind of this is one of my first drafts. So we're going to use a PIC 16F877 microcontroller, Squelch control input, scan. The actual ports that I'm using for a lot of this stuff has changed once I actually started physically building it. But the principle remains the same. I'll have an updated schematic once everything is finalized and officially complete and operating. From the rotary encoder switch, it'll occupy a full data bus, 8-bit bus. That'll be your inputs. I'm gonna have pull down resistors on here because we're going to disconnect it from the main board, and the pull down resistors are on the main board. So we'll have pull down resistors here attached to this bus here, and we will have another bus that will output to the PLL on the main board of the radio. We don't need any pull down resistors here because they're on the main board. Now we're going to have to occupy nearly an entire bus again for 7-segment decoders. So we're going to have to use the binary coded decimal 7-segment drivers to drive the 7-segment display. And unfortunately that means going on the circuit board and cutting all of these traces and soldering a wire to each and every one of them and bringing them over to the 7-segment controller. So it's going to make this a little more time consuming than it is. It's not going to be a simple plug and play mod. I mean, technically, ideally, it could be a simple plug and play mod. The only downside to it, without interfacing the 7-segment display, is you won't know what channel the radio is tuned to when the squelch breaks when you're scanning, because it'll just show you whatever channel the rotary encoder is selected. I've started building the actual scan interface. I've got my input, pull down resistors on my input, and they go to one of the ports on the PIC 16F877A. Full port is the output. I got 2 7-segment drivers over here. I got a header over here that I'm going to use to control the 7-segment displays, decoupling capacitors on everything, pull down resistors wherever they should be on the inputs to the 7-segment drivers, input from the rotary encoder, pull down for input to the PLL are on the main circuit board of the radio, so I don't have to add those to the circuit. Power input to the circuit. I've got my capacitors, stabilizing capacitors for the oscillator. The actual 20 megahertz oscillator is actually underneath the microcontroller, kind of in the cavity for the socket. Yeah, it was a very, very, very shallow crystal oscillator, and kind of worked out nice. I was able to install it underneath, hidden away, because I was kind of starting to run out of room in this area here. So that leaves the tuning interface pretty much figured out and ready to go. The only thing we haven't figured out yet is the feedback interfaces, the push to talk, and the squelch interface to tell the circuit if the squelch is open and stop scanning. So underneath the hood of the radio, so I looked in the vicinity of the audio output amplifier, because naturally that's where we're going to find one of our outputs for our squelch control, because basically all the squelch is going to do is it is going to mute the output audio when there isn't a strong enough signal or no modulation present. So I probed around in this location with my meter here while adjusting the squelch, and I ended up finding a jumper right on top of the board, jumper 37, which made it really easy to tack a little wire onto. And this jumper is actually right below. There's a little diode here, diode 69. It's right below that diode. When the squelch is closed, it sits at about 4 volts. My meter's reading 3.79 volts, but I've had some issues with this meter. It's not 100% accurate. When the squelch opens up, drops to 0 volts. So we should be able to use this as a logic level low trigger for the input on the microcontroller. Depending on how much current I'm not sure if this portion of the circuit here, I have to try and figure out where this is on the schematic yet. I'm not sure if this is sourcing or sinking current, and I may have to add a pull-up or pull-down resistor, or it might be able to sustain enough source current or sink current as it is without an additional pull-up or pull-down resistor to directly drive the input on the microcontroller. And the microcontroller will accept an input from anywhere between, I believe, the minimum for logic level low on the PIC 16F877A is 2.5 volts, between 2.5 volts and like 5.2 or something like that. So anything over 2.5 volts, it's going to see as a logic level high. Anything below that, it's going to see as a logic level low. So this should work absolutely perfectly as our feedback for squelch control. And just to show that this doesn't just work with the little dial here, I've got my handheld. Turn it on. Channel 5. Radio's tuned to channel 5. Set to low power. I'll key it up. There we go. So we should be able to get some form of feedback from that jumper there. Though we'll figure out in testing if this is true or not. I'm not at that point yet. Lastly is the push-to-talk feedback. I've decided to put this in for an additional delay, just in case you hear a signal, you respond to somebody, and they take a little bit of time to respond to you, or conditions aren't great and you might have to listen for them to respond a couple times. So basically what I've decided is in the code, I'm just going to make this delay twice as long as the squelch delay. Just gives you a little bit more listening time, because if you're going to key up the microphone, you're basically telling the computer, I'm engaging in this conversation, so I want you to stick around here a little bit longer. I might also make this an adjustable delay so that you can adjust it to your preference. I haven't decided yet. We'll see how that goes. I'm going to get the rest of the circuit working first. But for the push-to-talk feedback, pin 1 is grounded on the radio. That's the shield in the microphone. So when you push the PTT button to the transmit section, you are bridging pin 3 with the shield. You're basically shorting pin 3 to ground. So we should ideally be able to use pin 3 directly as an input on the microcontroller, with or without a pull-up resistor, in order to control the push-to-talk feature. And the final step to this is we're going to have some kind of a control to initiate scanning. Chances are what I'm probably going to use is I'm going to use one of the useless buttons on this radio, such as the Roger beep button or the instant channel 19 button. Currently I was messing around with trying to listen to some freebanders, so they are these buttons they're set up for the channel mods for the PLL. But I'm going to probably use one of these, and if I can find a control that I haven't commandeered on my Galaxy for a different modified feature yet, I'll use one of those. I'd much rather try and keep the radio looking as much stock as I can without drilling holes in the side of the damn thing. But we'll see. I'll have to go and open it up and see what's still left that I don't use for features on that radio, and commandeer one of the controls. I've already taken the Roger beep control, and I've taken the talkback control for mods. So there's I've also taken some of the front plates, the switches, like the tone control mod, because I always leave it on medium tone and stuff like that, for additional mods on the radio. So there's not much left on the face of the radio without drilling a hole and adding a switch. So that'll be one of those things I'll have to figure So that the switch for scanning is basically going to be pretty simple. It's going to have a pull-up resistor on a input pin on the microcontroller, and when you push the button, it's just going to short it to ground. Simple enough. So that's where I'm at currently with the R&D for this mod. The next step is going to be getting the dial out, which I believe the display is all one PCB, and figuring out how I'm going to separate the traces from the 7 segment. I'm not sure if I'm just going to chop off a chunk of the board yet and just hook up individual wires to each of the segment driving pins on the display, or what I'm going to do. I got to get it out, take a peek at it, and then once I figure that out and figure out how I'm going to do it, get that wired up so I can plug it into the headers on the board and create a interface cable to go between the rotary encoder to the input of the interface, and from the interface output to the PLL socket on the board, and then start writing the code, trying to get it to work, debug it, get the proper delays and scan rates and all that fun stuff. And once the basics are working, then I can start adding features. So stay tuned. This is a mod that I'm definitely going to complete. It might take a while. It really depends on my schedule and whatever else I've got going on at the time. But this is a definite mod that I'm planning on completing, because it's just one of the things that I think, with all the crap they got in the radios nowadays and stuff like that, I just think that you should be able to hit a button and scan through 40 channels and have it pop up on a channel that's got a signal on it.